Okay, here we are, section 14.4, area of triangle. So you may say, I don't need this, I know the area of a triangle. It's 1/2 base times height, and you would be correct. That is true. If you know a base, and you know the length of the altitude from the opposite side of that base, which we call the height, you can plug those in to find the area. But with trigonometry, we can actually create a little more sophisticated equation. And that equation can be found on your cheat sheet, so I'm going to show you that because you don't have to memorize it. So it is sitting right here across from our friend law of cosines, which we just met. So I'm not here to prove this because it's not something you really need to be able to do, but if you want to see where this equation comes from, you can go to page 560 in your book. I'll sort of hint at where it comes from. Also the log cosines, I don't think I mentioned, but if you want to see where that equation comes from, that's on page 552 in your book. So anyway, I would think that maybe knowing that you need a base and a height to do an area that, and let me just go ahead and write the equation actually as it's written, 1/2 AB sine C. So in any case, if you didn't know what the height was, I think it might start to be making a little bit of sense to you. Maybe like you need to know what this height is, and if you happen to know what the length of one of the sides was, so if we just sort of look at one side of this triangle, we have a situation where we know a hypotenuse and an opposite if we're looking at this angle, for instance. And so you can start to see how sine might be something that you use if you're sort of in the process of trying to figure out what your height is. And so basically what this equation does is it kind of fits everything in together so that you can just go for it and figure out the area without having to do this in pieces, figuring out your base and your height. So similar to the law of cosines, not all problems are going to be served up like perfect so that the angle you know is C. So you should have the ability to rewrite this. So another version would be 1/2 BC sine A, and hopefully pattern-wise you see it's pretty straightforward. If a C is here, the other two variables go here. And also then the last one would be 1/2 AC sine B. Now in addition to that, there's a possibility that you'll have some triangle that doesn't even have A, B, and C in it, maybe D, E, F, as in this case. So as I said before, I just recommend you draw the picture. So I'm going to go ahead and draw DEF in this case. So this example, we're going to find the area, DEF, given DE equal to 14, EF equal to 9, and the measure of angle E equal to 30. So we need to find the area. So if this was on a Regents or on a test for this class, you'd hopefully say to yourself, whoa, wait a minute, I know there's an equation, it's on my cheat sheet. And so I would just go there, get that equation, and grab it and write it exactly as you see it. So K is equal to 1/2 AB sine C. And then what I would do, and one option is you could change the lettering of your triangle if you would like, if that seems like something that would help, which, basically all you would do is say, okay, I'm going to call angle EC and then relabel it ABC. Or the other thing, which I kind of seem to do more often, I don't know why, it just happens to be the way, is I know what E is, and so I'm just going to go ahead and then have this be sine E, and then I need to put a D and an F in. Okay, so now it's a fill in the blanks game, and I'm going to go ahead and label up my triangle here though. So this would be side D, this would be side E, and this guy here would be side F. So this is going to be a 9 going in here. For F I have a 14, and then the sine of 30. And if you've become familiar, you might realize that really all that really is a half, but your calc would be happy to do that for you. Just make sure when you're using this equation that you are in degrees. And so when you multiply these things all out, you get 31.5 square units. Now, if for some reason the angle that you were given was not in degrees, then you would want, if you were told it was in radians, then you'd be in radians for plugging that in. Okay, so now I just have two more examples that are just different applications. That's the theme of this chapter, applications of trigonometry. So, adjacent sides of parallelogram ABCD measure 12 and 15. The measure of one angle is 135. Find the area of the parallelogram. So, draw a picture. This is the picture I have a tendency to draw when I draw parallelograms. So I'm going to label this 135 because my eyeball is looking at it. It looks like that's the obtuse angle. And then I have two sides, so we'll call this 12, we'll call this 15. And I need to figure out what the area is. Now this is an area of a parallelogram. So if you remember back to your geometry class, hopefully you remember that if you draw a diagonal in here and just figure out what the area is of one of these triangles, you can double that, and that will be the area of your parallelogram. So I'm going to go ahead and write my equation down. K equals 1/2 AB sine C, and since I'm in charge, I mean, I can label this parallelogram up any way I want, and so I'm going to label it so that it works for the equation. So I'll go ahead and I'm going to label this guy C, this guy A, and this guy B. So right now I'm just looking at the triangle, the lower half triangle of this, and I'm going to start filling in my blanks. Now to make this problem just be one where I can show you another thing you might need to be careful with, we're going to say that I want to get the area as an exact answer. And notice there isn't anything in this problem like that's suggesting how to round it, but normally it would be said given it as an exact number, and exact means in simplest radical form. Okay, so to start plugging in my information here. So now if it helps too, the other thing you could do is redraw your triangle so that you can really clearly make sure you're labeling the right thing. So this is 15, this is 12, so that would be little a, and then this guy down here is little b. I don't care about little c because I don't need it in my equation. So then I'm going to go times 12 times b, which is 15, times the sine of 135. Okay, so once again, since I've added the word exact, I need to think a little bit differently about this. So I have 1/2 times 12, which is 6, and I have 6 times 15, which is 90, times the sine of 135, and the sine of 135, whether you cheat with your calc to get it or you remember it, is radical 2 over 2, which would then be 45 radical 2. Now this is the place I personally have a tendency to make a mistake, and that is making sure I answer the question, which I'm supposed to be figuring out the area of the parallelogram. So the area of ABCD, the parallelogram, is just going to be twice the area of that triangle I just found. So in the end, this answer is 90 radical 2 square units. So hopefully you can see, like, these problems are really not bad. It's just saying, oh, that's an equation, I know where to find it, I'm going to get it on my paper, and I'm just going to try to fill in the blanks correctly and answer the question that's in the problem. Okay, one last one. 3 streets intersect in pairs enclosing a triangular park. Distances between the intersections are given here. Find the area of the park to the nearest 10 square feet. Be careful, that doesn't say to the nearest tenth. So let's draw a picture. So I have 3 streets intersecting. Hopefully you can imagine this, creating a triangle. One of the streets is 85.5, another one is 102, and the last one is 78.2. Okay, I'll just go ahead and label this up. Use a different color so you can see it. A, B, C, and then I'm going to label the sides across too so that I have everything I need. Okay, so in this case, in order to find area though, if you remember, we need an angle. So like if I say, oh yay, it's an area problem, I like these problems, hopefully your brain will say, well, wait a minute, I need an angle. Now, how am I going to get an angle? Well, it just so happens I have 3 sides. So the perfect way to get an angle, since I know the 3 sides, so I can plug all this in, is the good old law of cosines, because then it will allow me to find the cosine of an angle, and then I can find that particular angle. So I'm going to go ahead and I'm going to just copy right from the sheet my law of cosines. So a squared equals b squared plus c squared minus 2bc cosine a. So one option is you could go ahead and just plug the numbers into these positions, and you're going to plug all this in, and then you're going to have to move things around a little bit, and then you'll figure out what the cosine of A is, and then figure out what A is. I personally, because I think it ends up being a little cleaner in the end, like to first solve for cosine A. So like I did before, I'm just going to pick up this negative minus 2bc cos A and bring it over to the other side. So it's going to become 2bc cos A equals b squared plus c squared. And I'm going to pick this a squared up and send it over there, which really is like subtracting that from both sides. So I'm going to subtract that. And now I'm going to solve for the cosine of A. So I'm going to divide both sides by 2bc. And now, since in this case I actually want to know what A is, I'm going to go ahead and just go for the gusto and write precisely what I need to do. I'm going to take the cos inverse of this thing I just wrote. B squared plus C squared minus A squared all over 2BC. So now all I got to do is I just plug into this thing and I get what I need, but I won't be quite done with the problem. Now I'm going to just let this drive itself as far as the way my labeling is worked out, and then we'll take it from there with the next step of this. So I'm going to take the cos inverse of what I get when I put it in b squared, so that's 78.2 squared plus 85.5 squared minus 102 squared, all divided by 2 times 78.2 times 85.5. Now, the most dangerous part of the operation is order of operations with your calculator. So if it was for the purposes of space here, I'm not going to do a bunch of steps to get this through this, but I am going to tell you what I would do personally. Like, I would probably on my calc put in 78.2 squared plus 85.5 squared minus 102 squared and hit enter. Now I could like be careful and use parentheses if I want, or else get the fraction notation up, which would be fine too. And then I'd hit enter, and then I'd hit divided by, and then in parentheses I would put 2 times 78.2 times 85.5, close my parentheses, and hit enter. So that would give me what my cosine value is. And on my paper, if I was doing this, I would, write down a good couple of decimal values, and just to show if someone was grading it what I got. But I would just leave that sitting on my screen, and it's the form it's in, and then I would hit second cos second answer so that whatever I get that comes out is actually accurate. And so on my paper, I'm not going to write it all, but something along the lines of 76.94. I'm just trying to help you prevent rounding errors, because that can be a problem. And just order of operation errors. Okay, so what I've actually found here then is what angle A is, which now leads me back to being able to figure out my area. So I say to myself, okay, I have that equation, and they were so nice, they gave it to me on my cheat sheet. So the equation is k equals 1/2 AB sine C. Okay, so I'm going to come back over here and I'm going to write k equals 1/2 AB sine C. So I have a slight problem just because of the way these equations are written on my sheet. My law of cosines refers to a cosine of A, and my area equation refers to a sine of C. So it's like we're talking different angles. So what I would do in this case is, since I figured out what angle A is, I don't feel like relabeling my diagram. I am just going to change this equation to work for the angle that I know. So I know angle A, so that would be sine A, and so that means that in this position I need B and C. I mean, if you notice really what's going on here to find this area is I have B and I have C, and then it's the included angle, and that's going to happen, whichever angles or sides that we use. So now I'm just going to plug some numbers in. So 1/2, and when I'm all nice and labeled up neat, I can easily just plug in, times the C, which is 85.5, and now I have a little bit of a space problem, I apologize, times the sine of 76.94. Okay, now, once again, just talking to kind of prevent rounding errors. If it was me, I would still have this 76.94, whatever it is. It's got more decimals after it sitting on my calc. And I would probably just go ahead and hit sine, second answer. So I get the accurate value of this, and then times 85.5 times 78.2 times 0.5. And you would get something that was approximately 3,256, and I hope you're going along with me so you can make sure you're good with what buttons to push. And then, since this says to the nearest 10, can't quite walk away yet because I need to now look at this thing and say this is my tens position and that number is bigger than 5. So to the nearest 10 then, this is going to be 3,260 square feet. Okay, there you have it, your next application of trig. And you should head on over to Math Excel because I picked out a couple problems over there to help see if you're getting this stuff.